Hi students, welcome to Engineering Graphics class. I am Dr. Vinodkumar. We are going to discuss a very interesting question today. A sphere 80 mm diameter is sitting on the ground. A sphere 80 mm diameter is sitting on the ground. It is cut by a cutting plane 20 mm above the center. A horizontal cutting plane 20 mm above the center. The top piece is removed and an equilateral, largest possible equilateral triangle is inscribed in it. Draw the isoprojection. That's the question. I repeat. A sphere is resting on the ground, 80 mm diameter, 40 mm radius. It is cut by a horizontal cutting plane, 20 mm, passing through 20 mm above the center. Horizontal cutting plane, 20 mm above the center. After removing the small portion, the largest possible equilateral triangle is inscribed in the circular face, cut circular face. Draw isoprojection. Agreed? Okay. We have to draw plan and elevation. Plan, elevation. Then what? You have to draw the cutting plane. Where is the cutting plane? 20 mm above the center, draw a horizontal line. That's the cutting plane. When you remove this, what happens? You see a new circle. Where is that? This is it. This is the new circle. This is the new circle. Agreed? This is C dash and O itself becomes C. Agreed? What is this distance? This distance is not known to us. Let us name it as D. We don't know how much it is. Let us name it as D. Draw an isoscale. Draw an isoscale with D as side so that you get iso of this distance. Iso, this is D. This is D. So this is iso D. Take iso D and construct a rhombus. Construct a rhombus whose side is iso D. 30 30. 30 30. What is the side? Iso D. I hope you understand. Iso D. That is D. This is iso D. Construct an ellipse inside. Larger diagonal. You are drawing isoprojection. You are constructing an ellipse inside. What is the major axis of the ellipse? Major axis of the ellipse must be equal to D. Isoprojection D. Take half of D to either sides. This is the center. Don't draw arc. Instead, you have to draw smooth curve. Why so? You are drawing corrected ellipse. If you don't draw corrected ellipse, what happens? If you draw arc with this as center, this as radius, it will pass through inside and the major axis will not be D. You have to make the major axis D. The isoprojection of a circle is an ellipse with the major axis equal to D. That condition has to be satisfied. So I am mixing first center method and the point method. That's all. Okay. Now, if you want, you can draw a square here. So that this square is 1, 2, 3, 4. And this is 1, 2, 3, 4. 1, 2, 3, 4. For clarity, I am doing it. Now, what is this point? This point is C. Where is O? This is the distance of the height of the cutting plane, 20. So, where is O in our case? O is iso 20 below C. Measure iso 20 down. Somewhere here you get O. This distance is iso 20. Now what? O a center and what is the radius? 40. 40 as diameter. Draw a circle. You can see the circle just become tangential to the ellipse. Just become tangential to the ellipse. So what you have drawn? You have drawn the cut sphere. You have drawn the cut sphere. This is 20, this is ISO 20, slightly less. Then draw the half circle. Now, where is the triangle? The largest possible triangle is inscribed in this circular face. Get the center of this side, measure 60 degrees, draw a line, measure 60 degrees, draw a line, connect them. This is the largest possible equilateral triangle. I call this P, Q, R. Where is P? P is at the center of 3, 4. See, P is at the center of 3, 4. P. Where is Q? Q is on the ellipse. Where? We don't know. What you do? Extend this and cut the square at 2 points. Here and there. On the way from 1 to 4, locate this point. On the way from 1 to 4, locate this point. On the way from 1 to 4, locate this point. Can you directly take it? No. You have to go to iso scale. Find the iso length. There are some distances to be marked. 20. This is 20. This is the iso length of 20. 40. Okay, that is taken. So this is this small distance. I can call this M. 1m. This is M. 1m. Agreed? Take that distance. Mark it here. What do you get? M. Same is this distance, no? So mark it there. N. Connect Mn. Very light line. What is this? This is Q. And what is this? This is R. Connect PQR. PQ, QR, RP. You have got the equilateral triangle inscribed in the circular face. Similarly, this is over. The question is over. Question is over. Okay. Now, if the iso view is asked, suppose you are asked to draw iso view, what will you draw? You will not draw isoscale. We will draw a rhombus whose side is, instead of iso D, whose side is equal to D. Draw the ellipse whose major axis is not equal to D, but D divided by 0.815. Then from C, measure 20, instead of iso 20, measure 20. Then with O as center, what radius? 40 divided by 815. We will draw a circle. And then we will draw the equilateral triangle. Instead of 1m, you directly take 1m there. Instead of going to isoscale and taking, directly take 1m. That is iso view. So I am just discussing what differences will be brought in when you draw its isometric view. Now, similar to this equilateral triangle inside this circular face, you can have a hexagon, you can have a pentagon, you can have a square, etc. Agreed? So it is necessary that you draw the plan and elevation. D you can find out only if you draw the elevation. Then only you will get the diameter of the circle and then the side of the square. This side of the square is equal to the diameter of the circle, which you will get only if you draw the elevation. That's very important. I hope you understand. It's a nice question. If you are thorough with concept, you hardly take 10 minutes to draw. Otherwise, this can take you to trouble. Okay. Thank you.